Hi guys, welcome to practical session number 4 for COSC210 database management systems. Today you'll be building your own database driven applications. What we essentially mean by that is that you'll be connecting up a Java application to your database to extract and create records in the tables inside. Now the reading for this practical session comes from chapter 13 of the textbook, so there's some interesting concepts introduced there, so go through and have a flip through that. Today we're going to do an introduction. We'll go through some housekeeping just to get you up and get your applications connected up, or required to get your applications connected up to PostgreSQL on Turing. We'll go through a couple of examples to brush up on Java. Most of you should have completed the Java course already, but as long as you've done some programming before, you should be fine to jump in and start pulling apart the examples. Then we'll connect up our database and we'll use that to extract some records, and then we'll be doing some exercises where we create records in our database using our company database example. So today's practical session is all about connecting Java applications up to our database. In this situation, our database is, as usual, hosted on the PostgreSQL database management system. A data-driven application is basically any program that uses a centralized database to manage the storage of any form of persistent data. And it's achieved by connecting your Java application up to the database on the database management system and executing SQL statements to retrieve and manipulate data. So quite literally, your program will create SQL statements, send them through to the database, and retrieve the results of those queries that have been executed. So sort of in the same way that you've been interacting with the database through the PSQL client. Now, in order to connect your application up to the database, you'll need to specify a username and password. So we'll need to know who you're connecting to the database, who your application is connecting to the database as. Now, up until this point, you've been connecting to the database management system using the PSQL client, which automatically makes use of your UNE username and password. So, although you haven't needed to submit your password, the Linux operating system does that for you. You've been using that particular user with that password in the database. Now, that's not really a good situation, because it means in order to create an application, you'll have to put your UNE password in the application. So to get around that, we've created a new user account in the PostgreSQL server on Turing for each student, dedicated for use in your applications. So the username for your apps account, which is what we'll call it from now onwards, will be in the form of your username followed by an underscore and apps. So, and the password for that account will be your UNE student number. So for example, if the username was student1 and my student number was 1122334455, my apps account username would be student_1apps, and the password for that account would be the student number. So you can create and log into your apps account using the CreateDB application and the PSQL client. However, you'll need to override the Linux system on Turing from automatically logging you in using your UNE account credentials. So you do that by specifying a connection string on the command line. So you'll need to specify the -u flag, which is the account username. You've got the -w flag that'll force PSQL to prompt you for the password, and you'll need to set the host as well, just so it knows that it's Turing. That's just a little extra piece of information that's required by the application. So for example, I have an account called mwelch8_apps. So in order to create my first database, I'll use the CreateDB application. I'll specify using the -U flag that mwelch8apps is creating the database. I'll force it to prompt me for the password using the -w flag, specify the host, and the name of my database will be mwelch8prax4. When I do that, it'll prompt me to enter in the password, and when I'm prompted, I'll enter in my student number as well, or in your situation, you'll enter your student number in for that password. So once that's created, we can then use the same set of options, so the -u, -w, specifying the host, and as usual, we specify the database. to log in with the PSQL client. When we do that, we can immediately see it's exactly the same as if we'd logged in using our other usual account. Now the difference here is that when we go to connect up with our applications, we'll use the username MLChadeApps, and we'll use the student number as our password in our Java application. So we won't fall into the situation where we have to put our UNE account password in plain text into an application. So once you've successfully logged in your database, you'll be able to rebuild your company database. So we've done this every week. Again, we just use the \i command to upload prac01.sql. It should have created in the first week, and that will then load all of the tables and data into your database. So again, we'll be building on our employee database, a company database example. Note that when you run the SQL scripts in this way, you'll get some errors when you run them. These errors are for commands that attempt to change the owner of the relation to the account under which they were originally created. So recall that when we're creating our relations, we're running under the MLChadeApps user, and when we do that, when we do that, it'll create these errors because the original database was created under the mwelch user, so it's not the same user recreating it. You can ignore those errors; they don't mean anything. The default response to the errors in Postgres is to block them, which is what we want it to do. So just ignore any errors that come up when you do that, and you'll be able to keep moving through the prac. So, starting to work through our Java revision. So this section should be really quick if you've completed Comp 131 or Comp 132. Basically, it's just a quick revision exercise to call using Java. Here we have the ubiquitous Hello World in Java example. Recall that when we build a Java program, everything has to be inside a class, and we'll be using the main function today. So we've got public static void main, and we're printing out hello world using a system.out.println command. And once we've got our program written up, so you can put that into a file called helloworld.java, we can use the Java C application, so the Java compiler, to compile our Java into bytecode, which is stored in our class file. So that's done using the Java C command. We can then just enter Java. We can get Java to run our bytecode, which is stored in our class file, by entering Java and hello world. So that's a really straightforward example. So for processing user input from the keyboard, we can use the input stream reader and buffered reader. Here we have a quick example where we go through and we get some user input. We actually ask for the first name, the year in which you're born, the current year, and then we print them out in this example. Now, so if we walk through, we start by creating an input stream reader, and then we create a new buffered reader object and connect by inputting that input stream reader in as an argument. That'll return us a buffered reader. Now we can use the readLine function on our buffered reader to read in input from the keyboard. So when you run this program, it will display the text. It'll ask for each of these items, and as you go through, you can enter your first name, enter the year you were born, etc., and that'll be stored in the variables that you specify. One little trick that we've got here is the born year and this year variables are stored in integer type variables in ints, and in order to convert them from a string that comes out of our buffered reader, so we've got a string born year, we convert that using the parseInt function on the integer class. So that's a static function. We don't need an integer object. We can use it directly off the class. And when we do that, it'll calculate how many years old you are. So a simple example there of reading in input, converting string data to integer data. Most types will have a parse function. So if you were converting it to a float, you could use float.parsefloat as well. So go through and review those little revision examples just to get your programming in Java back on track. There's also a link here to a tutorial on the Code Project website, which will get you started if you have any further questions about reading input and output in Java. So this brings us to the exciting stuff. Now we're ready to write a Java program that connects to our database. Now, the first thing that we'll need to do is download the PostgreSQL database library and its driver. You can do that. I've included a link here to the Postgres, the .jar file that contains that particular library and the driver that you'll need. So what we do is simply unzip this. So we use the jar command and the -xf command to open this up in our prac number 4 directory that we've created for our prac. And this has just got to be in whatever prac we're using for today's practical. Today I'm using one called prac 4. So if we jump in and quickly unzip that particular item, we will be able to then access the library within it, and you'll have 2 additional folders in there. You'll have one called org and one called metainf. And by extracting them using this command, it'll make the libraries, so the files within, accessible to your Java programs at runtime. So we've given you a quick example here to see if you can get your drivers up and working. So the first program will simply connect to the company database that you created before. So up at the top, when we created our company database, it'll connect up to that. So in my particular situation, it'll connect up to my apps _pracs_4 database, and it'll list all of the employees and their first names and last names. Now, there's some important bits in this code that you have to change. You'll have to update the username for the database, for the database, and the username for the user, and you'll also need to put the student number, which is the password. So these functions are responsible for setting up the driver for the database. In our situation, we've got the PostgreSQL driver. We set up this connection string that has all of the location and the database that we'll be accessing. And then we have this get connection function on our driver manager, on the driver manager item, the driver manager class, to retrieve our connection to our database. And we'll be using this connection option down through all of our examples to connect up and execute SQL statements. So remember, we have to put the username and password, which is our UNA student number, for the application into that connection, that get connection function call, and we have to put the name of our database into the URL string, into the connection string that we'll be using. Once we've got our connection established, our program then goes and executes an SQL query. So we start by printing some bits and pieces out to the screen to make the output look all pretty. Then we start by specifying our first query. Now the query we're going to execute is we're selecting the first name and last name from the employee table. So it's a really simple query. All that's going to do is return a list of all of the first names and last names for the employees in the employee table. Now we start by creating a new statement object. So the statement object is created using the connection object. So we use the create statement function, which is on our connection object. Recall that we created our connection object up the top here, was a connection type object, and we used the driver manager class and the get connection function to create that object. Once we've created our statement, so we declare our statement, we create our statement, we then move through to execute the query. So we've stored our query, which is our select first name and last name from employee, in a string named query, and we drop that into a call to execute query on our statement function. And this will return a result set object. And we've named that result set RS in this example. And we can iterate through those results using a while loop and use this getString function to pull out the individual strings that correspond to the attributes from each row of data that's returned to that result set. So essentially what happens is when we call the execute query function, this query is sent through to the Postgres database management system via the connection that we've set up. it will go through and retrieve all of the employee records, pack them into a result, and send it back to our program, which will store it in the result set object. We then iterate through this result set object and return all of the attributes that we want to grab by identifying them by the name of the attribute here in this getString function. We then do some formatted printing to print them out in rows and columns, and we then finish up our program by closing the connection. Now, a few points to note in this program: we've got some try and catch blocks embedded in here as well. So all of the database calls will throw some exceptions. So we've got a class not found exception and an SQL exception that can result from our setup up the top here. So we've got to capture all of them. That'll be flagged to you at compile time. We've also got to make sure that we close off our connection. If we don't close off our connection, it can interfere with other connections to the database. So if we start another program up and try to connect up to it, it may not allow us to connect. Now that depends on the operating system. Usually it's fine, but it's good practice to close our connection to our database. So you can go and run that example. I've uploaded that one there. It's available for you to get hold of. I fixed up the tabbing in that file as well. So review dbtester.java, compile it and run it in the same way that we saw up above here from our Hello World example. We can go through now, and we're now ready to go through and look at some exercises for you. So what I've just walked through in the program, we go through in the prac here as well, so go and have a read of that, but it's what I just went through. If you're interested more about the formatting using the printf function, please consult I'll put a link in there to the Java formatted strings page, a quick little tutorial link there for you to review. Otherwise, it's time for you to start and have a play with that program. So, first thing you can do is modify the DB tester program so that it returns the first name, last name, date, and sex and salary from the employee table. So you'll do this, you'll have to add additional getString calls. You can then modify it so that it also displays the department name and department location. So you'll need to execute a join. You'll need to join two tables together when you execute this query. So you'll modify your query so that it joins the employee table to the department table, and you'll have to make sure that you get the appropriate attributes back out to print out to the screen. So go through those two exercises first, then we can move on to the second part of today's practical, which involves using our Java JDBC connection to create records. So now that we have the Java program connecting and bringing down data from our database, we can look at developing a Java program that modifies some of the data. We'll first look at a simple example that creates a new record in the employee table. So again, we go through the same process to connect up our database. So we specify our database name in the first part of the connection string. We specify the apps user and our UNE student number, which is the password for the apps user. We connect up to get our connection object working. We can then go and execute a query. So in order to create a record, we're going to start by running a create statement call, and we set up some additional arguments here to allow us to add new records to our database. So we've got the result set, which is scroll sensitive, and concurrent updatable. These two constants are available from the result set object, and we put them in to our connection statement. We then go through and we execute our select query using our execute query function again. Now, instead of just reading what's returned into our result set, we're going to use this move to insert row function, which is available on our result set, to insert a new row of data. So we first call our move to new insert row. We then use these update string functions to go through and load up, specify our attributes and the value of the new row, the values for the attributes in the new row. So we specify we want a first name, middle initial, last name, social security number, and we put values in for these. So I've got a new first name, our new middle initial, our new last name, our new social security number, and our new department number. And we use the update string and update function. So what this does is, in this part of the code, we're just creating our new row of data. We're building a new row of data to put in our database. We then go through and execute our insert row function, which will actually carry out the operation of inserting the row into the database. We then move the cursor back to the start of the result set object. So this will allow us to then go and print out and do more stuff with our result set. So this is really the key area to do that. And when we execute our program, we end up with our new name being inserted into our employee. So we might have more employee records here, but we can see our new name has been inserted with 41 records. So go through, this is the key block of code, as I mentioned, where we create our new row of data. So we specify the attribute and the value for our new row of data, and then we call insert row. Now, if we void any database constraints, so for example, if we don't put in a unique social security number, so recall that social security number should be or is our primary key for the employee table. If we put in a duplicate value in here, this will return an error and we'll end up with an exception being thrown when we do that. So it'll print out your exception in this code. So make sure that you choose a unique employee social security number to insert. So now the exercise for you is to combine the first sample program we looked at, which was getting data from our user, and building a little application that allows us to upload new employees to our database. So here we'll go through, we'll collect some information from the user by allowing them to enter in first name, middle initial, last name, social security, and department number, and any additional fields that we want to capture. So I think we're also saying that we want to grab some other any other attributes as well. We then go through and we modify this code here to actually update the value in our database. So you can go through, have a play around with that code, and in the end we'll have a nice little application that'll allow us to enter values into our database using our own Java command line application. So that's all we've got for today, guys, and if you have any questions about practical session 4, please let me know.